Okay, last up here, one last section, burial depths and then wire sizing. So your burial depth, the bottom line on this thing, anytime they ask you how deep should this conduit or wire be buried, you should be thinking about turning to table 300.5 in your NEC. Everything you need to know as far as burial depths is going to be rated in this table. So across the top, we sort of have what I'll call our wiring method. Along the left-hand column here, we have our environment or situation or where we're at. So across the top, right, we've got column 1 through 5. Column 1, direct burial cables or conductors. That's anything with your UF cable, generally. We'll have an exception to that here in a minute. Column 2, rigid metal conduit or intermediate metal conduit. That's types RMC and IMC conduit. Pretty straightforward. If we're in RMC or IMC, we're in column 2. Column 3, non-metallic raceways listed for direct burial without concrete encasement or other approved raceways. That's a really common column. Non-metallic raceways. That's PVC conduit. In the field, you're generally doing underground wiring in PVC conduit because it's cheap and easy. You're generally not doing concrete encasement unless you have to, because that's expensive and it takes a lot of time. So you find yourself in column 3 quite often. Column 4, this is essentially your residential post light exception, I like to think of, right? Very specific. Residential branch circuits rated 120 volts or less with GFCI protection and maximum overcurrent protection of 20 amps. So we got to be in a residential situation. It's got to be 120 volts or less. It's got to be GFI protected. Can't be over 20 amp circuit. Once again, that is a residential outdoor circuit, your post light kind of thing, all day long. Very specific on how you qualify for column 4. Column 5, irrigation landscape lighting. That's low voltage lighting. I'm not even going to mention that. You hardly spend any time in there. But those are your columns, right? I'm going to say 1 through 4 because 5 we can almost cut off this thing. But so now where are we at, right? This is how we're wiring up here. Where are we at? All locations not specified below. If you go through all this and you don't really fit in any of this, you default to this one. What do you notice? 24 inches. That's the deepest, right? Over here they give you 6 inches. Not really sure what the exception is there. But again, if you don't fall into any of these columns, or any of these rows, you're coming back up here to row 1, right? So down here to row 2, in a trench below 2-inch thick concrete or equivalent, pretty straightforward. Is your concrete above it? Is it 2 inches thick? If it is, we're here. Under a building, this one's interesting. Under a building, we don't have to bury it at all, 0 inches. Well, if we're under a building and we go less than 0 inches, what happens? Well, now we're in the building. Okay, we ran our wire in the building. Not a problem. So this, I feel like this is almost an inside joke or something. I don't know. But under minimum of 4-inch thick concrete. So just like this guy, but now 4 inches, right? So notice most of these measurements got a little bit less. Some stayed the same. But under streets, highways, roads, alleys, driveways, and parking lots, spend a lot of time in this row, because when you're doing outside wiring in a commercial environment, usually it's for site lighting. Site lighting, where does that go? It goes around the parking lot, right? So we're in this column. We're in this column. We're in this row. Hey, 24 inches. Well, that's kind of like worst case scenario. Notice that's the deepest depth on this whole entire chart. But this right here is where you find yourself most of the time. So 24 tends to be a go-to answer here for a lot of issues. Here again, we have 1 and 2 family dwelling, driveways, and outdoor parking areas, and used only for dwelling related purposes. So again, if you got that post lighting, you're going under the driveway now. Now we're down into this row. And then in or under airport runways. Notice that's not actually the deepest. I'm not entirely sure what that is. I'm imagining because there's some concrete encasement requirements there. But again, here's your burial depths. They ask you a question about a burial depth. What's our wiring method? What's our situation? 300.5, right? Okay, last but not least, I won't spend a ton of time because there's not a lot on the test. But they might say, and I think on the test it says, hey, here is some wattage and voltage. What size wire do you need? Well, we need to know the amperage to calculate wire size or to find wire size. So we need to use Ohm's law to find the amperage. They give us wattage, they give us voltage. Calculate the amperage using Ohm's law. Once you have the amperage, we need to say, are we using copper or aluminum wire? Unless given other specific instructions, if we're just trying to say, here's how many amps we have, what size wire do we need, we're going to default to the 75-degree column for various reasons I've gotten into before. I won't get into here at this point. But so are we using copper? If we are and they don't tell you otherwise, we jump in here to this 75-degree column. Come on down the list. If we're using aluminum, we come into this 75-degree column, come on down the list till we find our amperage. Come over here and relate that to a wire size. We have one exception to this table. We need to remember for 20 amp circuit. Let's start with the 15 amp circuit. For a 15 amp circuit, smallest wire I can use is 14 gauge. We know that from a couple points in the code, but notice here it's 20, right? So we have to be aware of that. The answer is, if I have a 15 amp circuit, I need to run 14 gauge wire. Same thing with the 12 gauge. That's good for a 20 amp circuit. Well, this says 25. For a 10 gauge, that's good for a 30 amp circuit. Well, this says 30. Again, you need to be aware of that fact. If you should happen to find an ampacity, that is, again, say 25 amps, I can't come in here and say, okay, I can use a 12 gauge because I know from other things, namely this asterisk, which refers me to 240.4D. If you check that, you'll see what I'm talking about. But we need to be aware, a 12 gauge wire can only be used on a 20 amp circuit. So basically these small conductors with the asterisks are the ones where we can't go straight by this column here, right? And you might ask, why do we have that higher value? That's for derating purposes. I believe you guys will hit derating in the second half here, but when we do, that'll all sort of make some sense. But again, there's your wire sizing. Hopefully this helps arm you guys for this midterm a little bit, and good luck.